Chapter 14, circular function. It will be exactly the same thing for year 12. You will learn the same thing again year 12. Okay, nothing going to change. Okay, I will teach you exactly the same standard as what year 12 required. Measure angles in degree and radius. So since now, from this chapter, when you have your calculator opened, there are two places you need to change your settings. Okay, we're not really using degrees too much now. Well, you still in year 11, you will still see questions in degree, like sine 180 degree, but most of the time you will have radian form. Okay, most of the time you have radian form. So I will just tell you which two places you need to change your calculator. You're not going to change it now. After I finish this, you can change it at home. So first, when you have a front page of your calculator, there's a setting button here. Number 2, document setting. Okay, in this document setting, you have the second line angles. Okay, mine just keep in radian all the time because like year 11, year 12, we use a lot of radian form, not using degree. I'll explain what is radian, what is degree later if you don't really understand it. And okay, there are two buttons, make default or OK. If you press OK here, if you make a change and press OK, which means you only save it for this time. When you turn off your calculator, open that again, you will go back to the original setting. So make default means you always save like that. When you turn off, turn on, it will be the same. Okay, that's one place you need to change. Okay, that's one place you need to change. Okay, then I'll press cancel. Mine saved already. That page, what you change is for the calculator page. Okay, you calculate, number calculation is in that page. But there's another place we must change it, which is the new calculator. Okay, before it's not the same. So if you have this calculator, you go to the sketching page. Okay, if you're going to sketch something, for example, you want to sketch sine x on this calculator, you need to change this as well, because what you changed before only changed the calculator page. This one is the graphing page. So you press menu, number 9, settings. There's second line got a graphing angle. You need to change that to radian as well. I have quite a few students coming to me to say why my graph looks ridiculously bad, because you haven't changed that. Okay, if you change that, the graph will look like sine graph or cosine graph. So if you're not changing that, you have some problem. So keep that in radian form as well. Okay, that's for graphing page. You just need to go to the graph page. You need to actually enter the graph page, press menu, number 9, and change that. Make that default. Okay, that's the two places related to calculator. That's something which is very serious problem. In year 12, you go to the exam without changing this, you can have all the answer wrong. Okay, everything is wrong. Okay, what is radian, what is degree? It's just two ways of measuring angles. Okay, it's two ways of measuring angles. It's like unit. You can say degree is kind of unit and radian is kind of unit. There's two kinds of unit when we talk about angles. So they are not, 1 degree is not equivalent to 1 radian. They are not the same size. Okay, what is 1 degree? If you think in a circle, my circle is too bad. Well, like, see, have a circle. What is 1 degree? You know that angle is 360 degrees. Okay, if you equivalently cut that into 360 pieces, 1 piece is 1 degree. Okay, is that easy? That easy to understand. That is easy to understand. Or if you have a straight line, that is 180 degrees. Okay, from here to here. If you cut that into 180 pieces, 1 piece is 1 degree. That's the size of 1 degree. Okay, the definition for radian will be different. The definition for radian will be different. Okay, let's have a look at the definition. First, before we talk about the radian, we think about unit circle. So what is unit circle? Unit circle is a circle with radius of 1 unit. Okay, so 1 unit. We have a circle, the R, this is 1. Okay, you have 1 unit of the radius. That's a unit circle. And what is radian? 1 radian, we written as 1 C on the top. Okay, a small C on the corner. So 1 radian, that's radian. How large is 1 radian? is the angle subtended at the center of the unit circle by an arc of length of 1 unit. Okay, it's a quite long sentence. So what that means? That's a unit circle. Okay, that's a unit circle. We have an angle here. That's 1 as well. I will say that's 1C, 1 radian. If this arc is 1, the length of this arc is 1, then that angle got a size of 1 radian. Okay, got a size of 1 radian. So on your arc, so what's the, how I can say that? What's the circumference of the circle? What's the circumference? 2 pi, right? 2 pi r. So 2 pi is the circumference. Because the radius is 1, so 2 pi r is 1, the circumference is 2 pi. So you have length 2 pi. The circumference, the arc, the whole circle is 2 pi. So 1 over 2 pi of that arc got an angle of 1 radian. So 1 is a length. Okay, so how large is 2 pi? It's about 2 times 3.14. It's about 6.28. It's about this length. Okay, one of that. Okay, one part of that got an angle of 1 radian. So if the arc subtended is 1, then the angle corresponding to that will be 1 radian. So similarly, we use this idea to think about what is pi. Okay, this is still a unit circle. This is still a unit circle. Then I have a straight line here. Okay, I have a straight line here. Okay, this angle is subtended by this arc. Okay, subtended by this arc. This angle is opposite to that arc. Okay, that arc has a length of pi. Has a length of pi. Okay, the full circle is 2 pi. Okay, half of it is pi. Then this angle will cause pi radian. If it's subtended by 1, it's 1 radian. Subtended by 2 is 2 radian. Now it's subtended by pi of the length, which is called pi radian. That's how large is that angle. And we can see what is pi radian equivalent to. Pi radian is 180 degrees. You know that is 180 degrees. Okay, a straight angle, that's 180 degrees. So what all I'm talking about is the definition. So the most important thing you know is pi equals to 180 degrees. Okay, pi radian is 180 degrees. So 2 pi is 360 degrees. Okay, 2 pi is 360 degrees. That is what we should know. Okay, I'll just go through the definition with you. Okay, the next thing we're talking about is how do we convert the angle between radian and degree. So we have thing in angle form. We want to convert that into radian form. What I need to do is I will times pi over 180. If from radian I want to go back to angles, I will times 180 degrees over pi. That's how do we convert between the two angles. Okay, that's how do we convert between the two type of units. Okay, because angle, you divide 180 first. See how many 180 degrees are there in this angle, and that times pi. Because if you have 180, you have pi. If you have 180, you have 2 pi. So how many 180 are there in this angle, and that times by pi? I will convert that into radian form. Same meaning back. Okay, how many pi are there in this radian form? And each pi equivalent to 180. So how many pi are there? I'll times that by 180. That's how do we convert between this angle. Okay, just a simple example. Let's say we have 320 degrees. How much radian is that? How many radian is that? This will equals to this times pi over 180. Okay, this divided by 4 will have 45. This divided by 4, I will have 80. And I can further divide by 5, that's a 9. And divide that by 5 is a 16. So this equals to 16 pi over 9. Okay, 16 pi over 9. Okay, I'll just explain this to you. Hopefully it will make sense. This pi get two meanings. Okay, one meaning is it is equivalent to 3.14 degree. Not 3.14. Blah 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 blah. Like later, like it's the pi. Okay, it's the irrational number pi. If your calculator is under angle form, when you put a pi there into circular function, it doesn't mean pi angle. It doesn't mean 180 degrees. It will mean 3.14 degree. Does that make sense? If your calculator is in angle form, your calculator cannot recognize pi as an angle. It will only recognize your pi as a number. So how large is pi? Pi is 3.14. Okay, so when you put pi into the calculator, you mean 180 degrees, but your calculator will say, oh, that's 3.14 degree only. Okay, it won't recognize unless you put your calculator in radian form. In radian form, the calculator can see, okay, pi is 180 degrees. Pi is equivalent to 180 degrees. So pi actually got two meaning. In radian form, it is 180 degrees. In the angle form, it will be only 3.14 degrees. Okay, it's totally different. Okay, it's totally different. 180 and 3.14. Think about the difference. So it's completely wrong if you set in the wrong mode. Okay, that's what I emphasize here. So 320 degrees will be 16 pi over 9. So in the radian form, you put 16 pi over 9. That means 320 degrees. But in angle form, you put 16 pi over 9. That is not 320. So it needs to be careful about that. Okay, so that's first exercise. How do we convert between the two units? Okay, let's have a look at the next one. Next one is defining circular functions. What is sine, cosine, and another circular function and tangent. So I will combine this together. I'm not sure how well you learned this in year 10. Okay, I'll just go through the definition quickly again. Okay, what is circular function? Circular function is sine, cosine, and tangent. Okay, what is sine, cosine, and tangent actually? Like, how do we know sine 30 degrees equals to what? Sine 50 degrees equals to what? How do we know all of these values? Okay, how this value has been discovered? That's the problem. So the definition for circular function is from unit circle. So a unit circle in the Cartesian plane. So what we will do is we sketch a unit circle in the Cartesian plane. Okay, xy. We sketch a circle here. That's a unit circle. Okay, all center at 0, 0. Okay, that's my center. Center at 0, 0. And I got length of 1. Okay, so what's this coordinates? What's this coordinates? 0, 1. Okay, what's that coordinates? 1, 0. How about this one? -1, 0. And the last one here? 0, -1. That's the four coordinates we definitely know. Okay, that's a unit circle. That's the definition of a unit circle in the Cartesian plane. And what is sine, cosine, and tangent? The next thing we need to know is how do we represent angles in the Cartesian plane? Okay, how do we represent angles in the Cartesian plane? For example, I want you to sketch an angle which is 150 degrees. How do you sketch that? How do you sketch that? Okay, we start from the positive side of x-axis, not from the y. Okay, we start from the x-axis, and it's like we turn this way. Okay, the angle go this way. So if you go anti-clockwise. Okay, this is anti-clockwise. You go anti-clockwise, which means it's a positive angle. If you go clockwise, that's a negative angle. So I want you to sketch 150-degree angle. What you will do is, from 0, 0, okay, this angle, this line, this red line here, which means the angle at 0 degrees. Okay, that's the angle at 0 degrees. There's no angle made between the positive side of x-axis. Now I want you to sketch 150 degrees. So you will turn 150 degrees to that side, which this angle will be here. About here. Okay, this angle is 150 degrees. So on the Cartesian plane, this angle is 150. This angle is 150. Okay, how about if I want you to sketch a negative 60 degrees? Okay, first you need to understand, we have all the angles. Not only from 0 to 360, we have all the angles. Okay, we can have negative 1,000 degrees. We can have 2,000 degrees. We can have any angle we like. Okay, you just turn around, around, and around. We turn one cycle is 360. 2 cycle is 720. Okay, we just keep turning. So I want to sketch negative 60. Okay, where is negative 60? Negative 60 will be here. This angle is negative 60 degrees. Okay, we need to know how to sketch angles in the Cartesian plane. Okay, and I want you to sketch another angle at, let's say 400 degrees. 400 degrees. Okay, how do we sketch a 400-degree angle? From 0, turn around is 360. How much I need to keep going? 40. Okay, I just sketch a 40-degree angle here. Okay, here. So I just turn from here. That's a 400-degree angle. You'll be the same position as 40-degree angle. Okay, when you sketch 40-degree angle, same position as this one. So they are the same angle. 400-degree angle and 40-degree angle, they are the same angle. Okay, there's no difference. All the condition will be the same, all the character will be the same, everything will be same because they are at the same position. So if two angles or more angles at the same position, they are the same angle. Okay, they are the same angle. Just see where is it. We just care about where is it on this Cartesian plane. Okay, where is it? I'll just take off this 400 angle first. And the minus 60-degree angle then, and I'll just investigate on the 150-degree angle. Now is the definition for sine and cosine. So what is sine? What is cosine? Well, it's a sine of angle and cosine of angle. So how do we evaluate those numbers? First, we have a fixed circle, which is the unit circle. It just be there. Okay, you can't move to anywhere. So circle is here, and you have a particular line because this line make angle with the positive side of x-axis of 150-degree angle. This line won't move. Okay, this line must be there. Therefore, there is a point of intersection between those two graphs. Between the circle and the straight line, there is a point of intersection, and you don't know the point of intersection, but calculator will know. Okay, someone will know. Someone can help you to work out this intersection by technology. So it's a fixed point. It's a unique point. You won't have more values. It's just that. So let's say we have x coordinates and y coordinates at a, b. Well, a will be a known number. B will be a known number because technology can help you to work that out. It's two functions, and you can find out the intersection. On your CAS calculator, you can work that out actually. Okay, so you don't really need to know how to do it, but I will tell you it's achievable. This coordinate is achievable. So what is sine and what is cos? Cos of this 150 is just equals to A, and sine of this 150 will be same as speed. Okay, the x coordinates of the point of intersection is the cosine of that angle. The y coordinates of the point of intersection is the sine value of that angle. So what is sine? What is cos? Sine and cos is when you sketch a unit circle, when you sketch an angle line, there is an intersection point. You have x value and y value of the intersection. The x value is cosine of that angle, and the y value is the sine of that angle. Okay, so that's how do we find all the sine and cosine values. Okay, that's how do we find all the sine and cosine values. And tangent will be easy. Tangent x tangent anything will equals to sine of that divided by cos of that. That's a formula. I think I typed it somewhere here. Okay, tangent x. What is tangent x? Tangent x is sine x over cosine x, which is the y value over the x value. So in this case, it's b over a. Okay, it's b over a. So you know the x value, x coordinates, you know the y coordinates, divide them, yep, you achieve the tan. Okay, so that's what is sine, what is cos, and what is tangent. This is the definition for the circular function. Okay, what are they? What are they? Next thing. Okay, we will introduce unit circle. We introduced that. The unit circle is a circle of radius 1 center at 0, 0 of the Cartesian plane. We introduced that. The unit circle is used to define sine, cosine, tangent. I have explained how do we define that. PXY is the point on the unit circle that is defined by angle theta, which is the AB point I'm talking about. Okay, this is the point of intersection, which is the angle is measured in anti-clockwise from the positive x-axis. Okay, so go this way is positive angle, go the other way is the negative angle. Okay, cosine x, okay, very important thing is those two. Cosine theta is the x coordinates of P, and sine theta is the y coordinates of P. Okay, in this case, point P is the point of intersection, which is A, comma B. And tangent x will be sine theta over cos theta, which is the y value divided by the x value, give you the tangent of 150. Okay, that's the definition for the circular function. The next thing is really important. Okay, what we're talking about here is very important because you use this for 2 years. Okay, it's like well, we have many ways of remembering that, but let's have a think first. Because the x coordinates is the cosine value and the y coordinates is the sine value. Okay, now let's think about in this unit circle. Okay, if I have the theta in first quadrant, if the theta is in the first quadrant, the point of intersection is positive or negative. Like I will have if the theta is in the first quadrant, I will have a point of intersection with the unit circle. What you can tell me about the x and y value of this point of intersection? Is that positive or negative? Both positive, right? Both positive means both sine and cosine will be positive. Okay, sine will be positive because that's the y value. Well, let's say cosine first. Cos will be positive. Sine will be positive. Therefore, tan will be positive as well. A positive number divided by a positive number, you still have a positive number. Okay, that's case number 1. Case number 2, if theta is the angle is in second quadrant, what you can tell about the point of intersection, xy coordinates? Minus and positive. It's a minus and a plus. So x coordinates is minus. Okay, point of intersection is here. X is negative and y is positive. Therefore, cos is negative. Sine is positive. How about tan? Negative. Okay, number 3. If it's in the third quadrant, what will happen? The point of intersection. Both negative. So both sine and cos is negative. Okay, cos negative, sine negative. Tan, how about tan? Tan is positive. Negative divided by negative is positive. How about the fourth quadrant? So x is positive, y is negative. X represents cos. So cos positive, sine negative, tan is negative. Okay, let's put all this information in. In the first quadrant, everything is positive. So we write a O here, which means everything is positive in this quadrant. And in the second quadrant, only sine is positive. We write S here, only sine positive. Okay, if the angle is in the second quadrant, only sine is positive. In the third quadrant, only tan is positive. We write T, tangent. In the fourth quadrant, only cos is positive. Okay, only cos is positive, only tan positive, only sine positive, and all of that is positive. Therefore, we have a quadrant called cast, C-A-S-T. Okay, I will remember from the fourth quadrant, C-A-S-T. Go anti-clockwise. Start from the fourth quadrant, C-A-S-T. That's how I remember that. So this is why we have the cast quadrant. Okay, that's why we have this. We will use this later. I will show you how to use this thing later. But we need to understand how this has been made. Okay, it's because sine is positive only in the second quadrant, tan is positive only in the third quadrant, and cos is positive only in the fourth quadrant. And in the first quadrant, every value is positive. Okay. We introduce this one. And the next thing we're talking about is these special angles. Okay, what is special angles? Special angles are the angle when you put that into sine, cosine, and tangent, it can give you a value, a nice value, okay, nice looking value. You can really write that down on the paper. Well, it's not necessary to be a rational number. It can be irrational. For example, root 2 over 2. It's an irrational number, but will make it possible to write the exact value on the paper. I will just put, okay, in my calculator, I will just put sine. Let's say we put sine. Well, let's put degree form first. Let's say 160 degrees. Okay, 160. Okay, degree is in pi. Okay, degree is here. Can you see the button? That's the degree. Because I set my calculator in radian form already. And when I try to type degree in it, I need to put the unit degree here. Okay, that calculator knows, oh, you're talking about 160 degrees. So I can add a sign on it to say that's 160 degrees. If you just put 160, it will be wrong. I will show you the answer later. I press the enter. And it gives me sine pi over 9. And I press Ctrl and enter. That will give me a value which is not nice. Okay, you have infinite many decimals behind. I can't really write down the exact values. Okay, there's no exact values. Let me just show you what's going to happen. If I just have sine 160 here. It's different value. Can you see it's different value? It's not the same meaning. Radian and degree, they are not the same meaning. Can you see the actual 160 degrees should give you 0.34. But when I just put 160 without the degree form, that gives me 0.219. They're not the same angle. Yeah, it's not the same angle. So you must write the degree on it. You can set your calculator in the radian form, but when you talk about degrees, you put the unit on that. Okay, you put the unit on that. So this is not a special angle. This is not a special angle. You can't really write the answer exactly on the paper. Okay, not exact form. So what are special angle? We have group 1 special angle. We are not going to go through group 2 today. So we only have group 1 special angle. So group 1 special angle are the angle 0, 90, 180, and 270. I can generalize that to say multiple of 90 degrees. It's a multiple of 90 degrees. Can you think about the position of those angle lines? Can you tell me where are they? Think about the position of them on the Cartesian plane. Where are they? All the axes, okay? X-axis or Y-axis is on all the axes. So all these angles on the axis. Okay, let's have a think. I'll sketch the first one. You do the rest for me. Okay, that's my unit circle. Okay, that's my unit circle. 0 degree. 0 degree is here, this angle line. The point of intersection is here. What's this point of intersection? What's that? 1, 0. It's a unit circle. That's the radius. So it's definitely 1, 0. Okay, the x coordinates represent what? Sine, cosine, or tangent? Cosine. X value represent the cosine. So cosine 0 degree is 1. Okay, here I have 1. Cosine 0 degree is 1. So what is sine 0 degrees? Sine 0? Sine is the y coordinates. So y coordinates is 0. Y. 1, 0. Okay, 0. Y coordinates is the sine. So y is 0. So sine 0 will be 0. Okay, sine 0 will be 0. How about tangent? Tan is sine divided by cos. So it's 0 divided by 1, which is 0. That's why it's special, because it just lies on the axis. I can know the point of intersection directly. I can evaluate that directly. Let's think about the next one. Pi over 2. Okay, how large is pi over 2 actually? Yep, pi is 180 degrees. Okay, pi is 180 degrees. Divide by 2, 90 degrees. Okay, pi, you should get used to this notation. Pi over 2 will be 90 degrees. So where is 90 degrees? Where is 90 degrees? Up, up. So turn 90 degrees this way, which is this line. Ah, my lines. Which is this line here. Okay, what's the point of intersection? 0, 1. Okay, sine 90 degrees, sine pi over 2 degrees. Sine will be the y coordinates. Okay, sine will be the y coordinates, which is 1. Cosine will be the x coordinates, which will be 0. What is tangent? Tangent is 1 sine divided by cos, so it's 1 over 0, which is undefined. Okay, you have no value for tangent pi over 2. It's impossible to get tangent pi over 2. It's undefined. Okay, it's undefined. It's 1 over 0. 0 cannot be the denominator, so you can't evaluate that. So it's undefined. No, it's undefined. Like when 0 is the denominator, it's not really infinity. Like we can't find a value. Well, infinity is also undefined. Infinity is also undefined. It means like I can't really say, you not say infinity, so you say undefined for this one. Okay, you can use the same way to find pi and 3 pi over 2 for me. Okay, I need those 6 values here. Give you 1 minute to do that. okay, is to see the point of intersection. So if you see any angle is multiple of 90 degrees, or say pi over 2, you will use this method. You will sketch it on the unit circle to see the point of intersection and say the value. Okay, where is pi? Pi is on this side of the x-axis. Okay, pi is here. The point of intersection is -1, 0. -1, 0. X coordinates represent cosine, so cosine pi is -1. Then sine will be 0. Sine divided by cos, you have 0. Sine divided by cos, you have 0. The last one is 3 pi over 2. Okay, 3 pi over 2 is here. Okay, that's 3 pi over 2. The point of intersection is 0, -1. 0, -1. Okay, sine is the y value, which is -1. Cosine is the x value, which is 0. Then tangent, again, denominator is 0, is undefined. Okay, that's this table. Check your answer. Do you have correct answer? Which is very important for this part. Okay, I'm not requiring you to remember this. Okay, I can't remember them. Like, I still need to have a think about it. So, how do you think about it? Is when you go to think, where is this angle? When this group 1 angle is the multiple of 90 degrees, you think about the position and you think about the point of intersection and evaluate that. Okay, that's the way of doing group 1 special angles. Okay, so what I want you to do is this question here, ABCDEF. Okay, I want you to evaluate those 6 questions. First, sketch the angle. Second, find the point of intersection. Third, evaluate that. Okay. Negative is turn clockwise. Okay, positive is anti-clockwise. If it's over 2 pi or over 360 degrees, it's just another cycle. Okay, you complete one cycle, you turn another cycle. So the position will be the same. Okay, position will be the same. So I want you to evaluate A to F. Okay, 2 more minutes. Okay, sine -3 pi over 2. Okay, 3 pi over 2 is 3 pi over 2 is here. Negative 3 pi over 2 is here. Okay? So well, you don't really need to sketch a circle, but like you can put the circle here, and negative 3 pi over 2 is go the other way, like clockwise, and you will meet at this point here. The point of intersection is 0, 1, so that equals to 1 because it's the sign value. Okay, sign value that equals to 1. Okay, cosine negative pi over 2. Cosine negative pi over 2. Okay, which will be here. Okay, which will be here. The point of intersection will be 0, negative 1. Because it's the cosine value. Because it's the cosine value. Therefore, we'll have 0. Cosine is x. Okay, that's 0. Sine 5 pi over 2. Okay, think about sine 5 pi over 2. That's a sine 2 pi plus pi over 2. Is that correct? That's a 2 pi plus pi over 2. So it's 4 pi over 2 plus pi over 2, which is 2 pi plus pi over 2. Why I have this 2 pi? Because 2 pi is a complete cycle. This will equivalent to sine pi over 2. You can add as much as 2 pi from that angle or subtract as much as 2 pi you can from that angle. Okay, you can keep adding 2 pi or keep subtracting 2 pi from an angle. That will give you the same sine, cosine, and tangent value. It must be 2 pi. It can't be pi. Okay, 2 pi. So sine pi over 2 is the same position as that one, which equals to 1 as well. Okay, same as that one, pi over 2. Okay, same position. So that is 1. Okay, 7 pi over 2. 7 pi over 2. So 7 pi over 2. I can subtract 8 pi over 2 from that. Okay, I can subtract 8 pi over 2. So I can have subtract 4 pi, which is 8 pi over 2. That equals to cosine negative pi over 2. Where is cosine negative pi over 2? Which will be here. The point of intersection is 0, negative 1. And I want cosine value, so that is a 0. That is a 0. Okay, tangent 5 pi. So tangent 5 pi can subtract 4 pi from that. That is just tangent pi. That is just tangent pi. So tangent pi is here. Point of intersection is negative 1, 0. Tangent will be the cosine value divided by this y value divided by the x value. Sine divided by cosine. So 0 divided by negative 1, you will have 0. Okay, you will have 0. Okay, last one, 9 pi over 2. So that equals to tangent 9 pi over 2 subtract 4 pi, which is 8 pi over 2. I can subtract 4 pi. That will give you tangent pi over 2. Okay, tangent pi over 2 is here. The point of intersection is 0, 1. But 1 divided by 0 is undefined. So you will say that's undefined. You say that's undefined. Okay, so the answer will be 1, 0, 1, 0, 0, and undefined. Okay, that's how you do this type of special angles. Okay, 14D is really, I don't know why it's there. Okay, it's just reviewing trigonometry ratios. Hopefully you know all the trigonometry ratios. Sine theta is the opposite divided by hypotenuse. Cosine is the adjacent divided by hypotenuse. And tangent is the opposite divided by adjacent. Okay, that's the 3 ratios you need to know. And we can apply this in the trigonometry ratios to the right angle triangle in the unit circle. So what that means? Okay, what that means? Okay, this is explaining why x and y coordinates are the cosine value and sine value. Okay, why they are sine and cosine value. So let's have a think of this unit circle. Have this angle theta here. Okay, I have OAB. So let's say in right angle triangle OAB. In right angle triangle OAB. Okay, what tangent theta equals to? No, cosine theta. Let's say first cosine theta equals to. Cosine theta equals to OA divided by OB, right? That's OA divided by OB. So what is cosine theta? OA is the x coordinates. What is the OB? OB is just 1. OB is just 1. Therefore, cosine theta is just x. Because it's a unit circle, the hypotenuse is 1. Okay, all the hypotenuse is the radius, and that is 1. So we have x. Cosine theta is just the x coordinates. Okay, sine theta is the same reason. Sine theta equals to AB divided by OB. So sine theta is AB is the y value divided by 1. So sine theta equals to y. So tangent theta equals to AB divided by OA. Tangent theta equals to y divided by x. Okay, that's how we use trig to represent the sine, cosine, and tangent value are actually that. Okay, cosine is this, sine is that. And tangent is that. Okay, how do we prove using trig ratios to prove that x, y is actually the cosine and sine value respectively? Alright, I'm not going to continue. We only finished 2 pages today. It's fine because I do a lot of definition here. You need to understand the definition and do enough exercise, okay? So exercise A to D, that's what we finished today. Well, they're all really easy and short exercise. So try some questions. You don't need to do all of them. Just try some questions from each exercise. And we will start next E tomorrow. Okay, we'll start E tomorrow.